Well, just finishing up my workout today and just kind of noticing the football field reminds me of today's lesson. Uh-oh, today's algebra lesson on the football field? Well, yeah, because today's lesson is on parallel lines and perpendicular lines. And check it out. Look at all those yard lines going across the field. They're perfect, aren't they? In fact, they're parallel to each other. Yep, all the yard lines on a football field are parallel to each other, and they'd have the same slope. Now check out the sidelines. What relationship do the yard lines have to the sideline? You guessed it, they're perpendicular. They form a perfect 90-degree right angle. Who would have thought? Algebra on a football field. Math on a tennis court too? Yeah, couldn't resist. Love playing tennis, and again, check out the parallel lines. The baseline, there in the back, is parallel to the service line, and that's parallel to the net, which is parallel to the other service line and the baseline on the other side of the court. And guess what? They're all going to be perpendicular to the sidelines, both the singles and the double sidelines. Another sport, more math. Well, the final stop today before we head back into the classroom is the baseball field. Now, you probably have heard of the baseball infield referred to as a diamond. Actually, it's a square. It's a square that has 4 equal sides, each of them 90 feet long. That's the distance from home to first, first to second, second to third, and third to home. I guess it doesn't sound quite so exciting when you talk about a baseball square, though, so they call it a diamond. Well, just looking at all the fields and seeing all the perpendicular and parallel lines makes you realize math really is everywhere. See you in class. We are back in the classroom now for lesson 5-6, and that's the lesson over parallel and perpendicular lines. Now, first of all, we're going to get some basic information about both parallel and perpendicular lines. So listen carefully and take really good notes. First of all, parallel lines are lines that lie in the same plane, in the same two-dimensional plane, and they never intersect each other. They never touch. So that's what's special about parallel lines. Now, if you think about that, if parallel lines never intersect, they never touch each other, that means they have the same rise and the same run, or in other words, parallel lines have the same slope. Now that's something that's going to really be important for our homework problems today. So always remember that if you know that 2 lines are parallel, then those 2 lines' equations will have the same slope. Now let's take a look at what's special about perpendicular lines. Well, perpendicular lines do intersect, and in fact they intersect and form a 90-degree right angle. Now that seems more like geometry. How does it apply to algebra? Well, we have to remember that perpendicular lines have slopes that are negative reciprocals of each other. That means if we know that one line is perpendicular to another line, and if we take those 2 slopes and multiply them together, it should equal -1. Or another way of thinking about it would be this. If your line is perpendicular to my line and your slope is 4/7, then my slope would be the negative reciprocal of 4/7, which would be -7/4. Or another example, again, if your line is perpendicular to my line and your slope is -3/5, then my slope is 5/3. So if you want the perpendicular slope, what you have to do is you have to take the first line's slope, flip it to get the reciprocal, and then change the sign to make it the negative or opposite reciprocal. Now again, that's going to really be important when we start doing our homework problems today. Pause if you need to, and make sure you have all the notes written down correctly. Let's take a look at how parallel lines and their slope affect our information that we need to come up with the equation of our line. Take a look at number 6. Now the information that we're given says that your line goes through the point 1, negative 3. So that's a point that we know is sitting on our line. And the additional information that they give us is that our line is parallel to their line in the books. So in other words, when we figure out the equation of our line, it's parallel and should have the same slope as the book's line, which is y equals 2x minus 1. So let's use what we know about slope-intercept form, because that's what that equation is in, and figure out the slope of the book's line. Well, as you can see, the m is right before the x in y equals mx plus b slope-intercept form, so the book's line has a slope of 2. Now, what that means is since our line is parallel to the book's line, that means our slope is also going to be 2. Now, we need to take this information and also the information about the point that goes through our line, the x1, y1, and we have to combine that information to somehow come up with an equation. How do we do that? Here's how we do it. We remember from lessons 5.4 and 5.5 that when we have information about our line as far as a point, an x and y coordinate that's sitting on our line, and also the slope, we take those values and we substitute them into either the slope-intercept form or the point-slope form in order to get the equation of our line. So you have to remember that after you find the slope of your line and after you've determined that you found a point that's sitting on your line, then take that x and y and m value and substitute it into either the slope-intercept form, which is what we did in lesson 5-4, or substitute it into the point-slope form, which is what we did in lesson 5-5. Now let's go back to example 6 and let's finish off our equation. Here we are back at number 6, and we can see that we substituted in the negative 3 in place of the y in the slope-intercept form. We substituted 2 in place of the m, and we substituted the 1 in place of the x. Now that leaves only the y-intercept b that's still unknown. So we go ahead and we solve for b, which means that we wind up with a y-intercept, a b value of negative 5. So that means we have both bits of information that we need to finish off our equation. We've figured out what the slope is, it's 2. We figured out that the y-intercept is negative 5. So all we have to do is substitute that information into the slope-intercept form to get our final answer of y equals 2x minus 5. Let's try another one just to make sure that you understand. Now in problem number 7, it says that your line goes through the point negative 2, 2, and is parallel to the book's line, which happens to be negative 3x plus y equals 4. Now, of course, we know by now that we need to use the slope of the book's line to figure out what our slope is, because since our line is parallel to the book's line, our slope is going to be the same as the slope of the book's line. So be careful though, because take a look at the equation that the book's line is in. It's not in slope-intercept form, it's in standard form. Now before we can determine what the slope of the book's line is, we better change that and put it into slope-intercept form. Let's do that right now. As you can see, I added 3x to both sides to get y by itself, which is what I need to do when I want to get an equation in slope-intercept form. And you can see that now the book's line is y equals 3x plus 4. So we can see that the slope of the book's line is 3. That means our slope is also 3 because our line is parallel and therefore has the same slope. Now let's go ahead and use the information that we have. We have our point, which has an x and y coordinate, and we have our slope. Only this time, let's substitute those values into the point-slope form, since we already have an example of slope-intercept. Let's do that now. Well, I substituted 2 in place of the y1, I substituted our slope 3 in place of the m, and I substituted negative 2 in place of our x1 in order to start the equation of our line, and now we have our equation in point-slope form, which is y minus 2 equals 3 parentheses x plus 2. Then the next step, I went ahead and distributed the 3. So I multiplied it times the x and times the 2 to give me y minus 2 equals 3x plus 6. And then finally, in order to get our equation in slope-intercept form, I added 2 to both sides, and that isolates the y and puts our equation in slope-intercept form. And our final answer is y equals 3x plus 8. Hopefully those two examples are real helpful in getting you to do your homework on parallel problems correctly. But we still have the perpendicular problems to do, so let's look at a perpendicular example right now. Here we have our next example, only this time we see that our line goes through the point -3, 1, but is perpendicular to the book's line. And the book's line is y equals 1/3 x plus 2. Now again, we have to use that information to figure out what our slope is going to be. Only we recognize that since our line is perpendicular to the book's line, that means our slope has to be the negative reciprocal of what the book's line slope is. Well, if we take a look at the slope of the book's line, it's going to be 1/3 because their equation is already in slope-intercept form. So if our line is perpendicular to a line that has a slope of 1/3, what is our slope going to be? Do you know? That's right. Our slope is the negative reciprocal of 1/3, which is -3. Now we have enough information to get the equation of our line because we have a point that's sitting on our line, which gives us an x and a y to use, and we know the slope of our line. Let's go ahead and use the point-slope form again, and let's substitute that information in and get our final equation. Well, I went ahead and substituted 1 for the y1, -3 for the m, and also -3 for the x1 to give us our starting equation in point-slope form of y minus 1 equals -3 parentheses x plus 3. Now just like before, I went ahead and distributed the -3 to give us y minus 1 equals -3x minus 9. And since we want our final equation answer to be in slope-intercept form, I isolated y by adding 1 to both sides to get a final answer of y equals -3x minus 8. So now we have the equation of our line, which is perpendicular to the book's line. Well, I hope you're going to be able to take this new information and build on the previous knowledge that you have from lessons 5-4 and 5-5. So tonight's homework should be pretty easy for most of you. So I hope you have a great evening, and we'll see you next time. Homework tonight. Do a great job. See you next time. Bye-bye.